Saxon's Calculus Lesson 60 is about derivatives of composite functions and then derivatives of products and quotients. And this is basically where, when I said make sure you derive every part, this is where, beyond a shadow of a doubt, you need this. So they remind you of a lot of things, of your formulas, and that we just talked about in an earlier lesson. And now let's jump into example 1. So if f of x equals sine of 2x squared plus 4x plus 6, find the derivative of it. So we know that sine is going to derive to cosine of all of this stuff carrying with it. And then multiplying with that is the derivative of all of this stuff. So that would give us 4x plus 4, dropping off the 6. And all of that should be in front technically. So 4x plus 4 in front of cosine with all of that. Example 2. Box that. If g of x equals natural log of the sine of x, find g prime. So we're going to do the derivative of natural log, which is going to take it to 1 over, and then the sine of x is carrying with it. And what is the derivative of sine? Well, that's cosine of x. So now I've derived all the parts, and we need to put that together. So that's basically cosine over sine. Ooh, that's the opposite of tangent. So that is cotangent of x for the derivative. Example 3. If h of x equals x squared plus 4x to the 100th power, find h prime. Oh, I guess I gotta put an equal there. So now we are going to assume that this is u as a u substitution to the 100th power. So this is going to be 100 u to the 99th, but that u is this x squared plus 4x stuff. And then make sure I derive it and get multiplying with 2x plus 4. Did they distribute or did they leave that? They did. Okay, so then 100 times 2 is 200x plus 400, and that is still multiplying with the x squared plus 4x to the 99th power, which I seriously doubt they did anything with. Oh, they kept it 200 parenthesis x plus 2, same thing, and then their other part. All right, now part B, derivatives of products and quotients. If f of x equals e to the x with x squared plus 1 to the 100th, find the first derivative. All right, since this is stuff that is multiplying, we need to 1d2, so e to the x, derivative of this one, which would go to 100, I'm going to change that to a bracket, 100, then x squared plus 1 to the 99th ends the u to the 100th with this stuff still plugged in, but I still need to derive this part, which goes to 2x, and that was merely 1d2 plus, so you see why these get complicated. The second one was x squared plus 1 to the 100th, derivative of the first one, which remains e to the x. Now, if you can simplify that, do, but I'm guessing, all right, so e to the x, then they wrote, oh, I might have written that 100 e to the, oh, how did they simplify this thing? X squared plus 1 to the 99th. I am not seeing their 100 with their e to the x. Okay, so I don't know what they did with their 100 yet. Plus x squared plus 1. Just a second. I'm going to pause it and see where they did something. found it. It's at the bottom of page 302. The only thing that they did was they put the 2 here with this 100 and wrote 200x e to the x with then this x squared plus 1 to the 99th power. And then you have, again, this x squared plus 1 to the 100th power. They said that is acceptable, and I would definitely take that answer. But some people prefer to have the answer in factored format. So they're saying what I can pull out from both is an e to the x. I can also pull out an x squared plus 1 to the 99th, even though this one is to the 100th power. So they are writing it with, I don't have a great deal of space here, but e to the x pulled out, the x squared plus 1 to the 99th power pulled out, leaving them with, not this, and we pulled that, so the 200x, putting those together, plus, and then one of these was left over because I only pulled 99 out, so that leaves x squared plus 1 also in here, and the e to the x we pulled out, which is why they wrote it this way on page 303. Okay. Now, example 5, f of t equals sine of 2t plus natural log of t over top of t cubed plus 3t. Are you already dreading this because I'm writing a lot here? Find f prime of t. Okay, so it's dividing quotient. So we're going to have to follow low d high. So the low part is t cubed plus 3t to the 5th. Low. Derivative of the top. Derivative of sine of, just a second. Yeah, that is 2t. Okay, just making sure. Sine goes to cosine of 2t. The derivative of 2t is a 2. So I'm going to cram that in front here. I don't need my dt's. Okay, then I'm deriving the top plus the natural 1 over t. Okay, now because this one is so complicated, I want to make sure that to the 5th, 2 with the cosine, 2t, yes. Okay, so low d high minus high, okay, so that's sine of 2t plus natural log of t is, so high d, oh, derivative of the bottom, oh boy, okay, so that goes to 5 t cubed plus 3t to the 4th, deriving the inside goes to 3t squared plus 3 all over, oops, didn't mean to slash that, square of what's below. So t cubed plus 3t. It already had a 5, so when I'm squaring that, I'm getting it to 10. Now, let me check this part, make sure I didn't miswrite anything. Minus, here it is, sine 2t, natural log of t, the 5, this part to the 4th, and this part. Okay, yes, now, can I simplify any of that? Probably. So, I definitely want the 2 in front. Doesn't really matter what comes next. T cubed plus 3t to the 5th cosine of 2t plus 1 over t. I don't think I want to do anything with that. Minus, I'm going to distribute the minus, sine of 2t minus natural log of t. Ooh, but that was all multiplying with other stuff. Hang on. Minus, sine minus. So I guess to avoid confusion, I would do a plus and then all of that since I distributed the negative already. And then I'm going to put that 5 here in front. T cubed plus 3t to the 4th 3t squared plus 3. No way they're distributing all of that, right? Are they Ooh, t cubed. Oh, are they both of them have the t cubed plus 3t. I think they're going to factor that out, leaving them 2 cosine 2t plus the 1 over t. Yes. Okay. I'm going to try to do their factoring. T cubed plus 3t. And I can only pull 4 of them out, leaving 2 with cosine of 2t plus the 1 over t. What I don't like about that is that written this way, this is going to multiply with 1 over t, and it's not. It's its own separate. I don't think I like their factoring. Just a second. Let me check the original, though. 2. Oh, this is a unit. Never mind. It is all together. This is multiplying with this. Okay, we're okay. Plus, and since this was pulling out, and this was my leftovers, pulling this out drops it from here, but it still has the 5, which would be negative 5 sine of 2t If, this 5 is distributing with these if I do it that way. If I leave it as, if I pull out the negative 5, that leaves me sine of 2t plus natural log of t because I pulled the negative piece out. And I still have, that was gone. I still have the 3t squared plus 3. And finally, I can close that because it was all multiplying with that. Yikes. Over top of, which we never dealt with, the t cubed plus 3t. However, if I pulled 4 of them out, I had 10 of those. I can cancel and drop it down to only 6 of these from the 10 that it was before. I could only pull the 4 out. Oh, and this, okay. Yikes. Factoring these, ooh, okay. Technically, I could only pull the 4 out as I did, but then I didn't write the extra one in here. So when I canceled out these 4 with the 10 that was down below, I still had this extra 1 that was out here that I should have written here. So that's why it's still out front as a single one with the 2 cosine 2t 1 over t plus the negative 5 still multiplying with sine of 2t plus natural log of t and the 3t squared plus 3. Whoo, yes, indeedy. That was a really, really fun one.